In this problem, what we're going to be looking at is we're once again going to be looking at electron and molecular geometries, but and in addition to that, we're also going to be looking at hybridization. So a problem reads, write the Lewis dot structure for COF2, which happens to be carbonyl difluoride or carbonyl fluoride. Determine the electron pair and molecular geometries as well as the hybridization. So in order to start, let's count the electrons. So we know carbon has 4 valence electrons plus the 6 valence electrons for the oxygen. And then each fluorine is going to have 7 valence electrons. So this is 10, 14, so we have to come up with 24 electrons. So carbon, being the most metallic, is going to be the central atom. We'll have a double bond to an oxygen. And then the fluorides will come off to the side, such as this. Should make a little bit better fluorides. Not that that's any better. And so if we count the number of electrons, here we have 8, we have 8, we have 8. So 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. So there's our 24 valence electrons. Now for the electron geometry, we always want to look at the central atom. And in this case, we have 3 bonding portions coming off the carbon. So for the electron pair, for that geometry, that's going to be trigonal planar. Trigonal planar. And since there aren't any lone pairs on the carbon, then the molecular geometry is going to be trigonal planar as well. Now for the hybridization, we can do it one of 2 ways. We can look at, and we can say, all right, since this is going to be trigonal planar, all right, the hybridization of anything that's trigonal planar is going to be sp2. It's going to be sp2. Another way we can look at is this is 3 orbitals, right? We have an s, we have 2 p's, so that means there's going to be 3 orbitals, and there's 1, 2, 3 things bonded to the carbon. So there's a couple ways to determine the hybridization. You can either look at the electron pair geometry, look at that, or what you can do is you can also just count the number of bonding things, bonding ligands, bonding entities to the central atom. And so an sp2 means there's going to be 3 hybrid orbitals, and so there's 1, 2, 3 things bonded to the carbon.